In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Could our sun have an evil companion? An undiscovered Death Star rotating at the furthest edges of the solar system? Does this mysterious star scatter destruction through the solar system at regular intervals, accounting for the greatest extinctions in Earth's history? Sifting through a realm populated by giant worlds and mysterious planetoids, scientists are on the hunt for Nemesis, the sun's evil twin. Of the billions of stars twinkling overhead, one may be a scourge to life on Earth, an evil twin to the sun named Nemesis. Some scientists suspect that Nemesis is a dark, still undiscovered star orbiting our sun. And every 26 million years, it triggers a disaster.
We know that the solar system is surrounded by this enormous cloud of comets, and so these successive passages of the sun's companion would send comets into the inner solar system. Some of them would hit Earth.
What follows is death on a colossal scale. It is now widely accepted that a rock from space caused the end of the age of dinosaurs 65 million years ago.
So we now are pretty convinced that the reason that a huge fraction of life on the Earth went extinct 65 million years ago was because a comet slammed into the Earth.
But astronomer Richard Muller has proposed a revolutionary theory to explain why that space rock crashed to Earth at that particular moment.
The Nemesis theory postulates that there's a star orbiting the sun at a 26 million year period. That's about it. Almost no other assumptions need to be made.
Muller believes that as Nemesis nears the sun, its gravitational disturbance sends comets flying through the solar system. The resulting impacts have been the source of many major extinction events in Earth's history. Muller explains how the theory came about.
Two paleontologists, when looking at patterns of extinctions, came across something that seemed utterly insane. They said that similar extinctions were taking place every 26 million years on a regular schedule.
The discovery of a 26 million year pattern of extinctions seemed impossible to explain by any process native to the Earth itself.
This is the sort of thing you dream about in science. It means there's something we don't understand. It means there's a discovery waiting. So I set about trying to figure out what that was.
Muller made an astonishing proposal. The only logical cause of these periodic extinctions is a cosmic stalker that orbits our sun every 26 million years, disturbing the comets on each approach. In short, a Death Star companion to our sun.
If this star is discovered, it is so important. It was a major player in the evolution of life on Earth. Without this, perhaps the dinosaurs would still be here.
If Muller is right, humanity itself could owe its existence to the Nemesis Death Star. After all, each mass extinction wiped out vast numbers of species, but each also cleared the way for new species to arise, including, ultimately, humans. We can witness the way Nemesis would have altered evolution on Earth by looking at a controlled burn on the Santa Rosa Plateau in California.
So every now and again, some cataclysmic event happens that wipes out a huge number of species here on Earth. And this is just like happens with these controlled burns, where the burn wipes out a number of species, which then makes room for new things to take hold. So, I'm seeing a fire raging behind us. What's going on there? Why do you light fire?
We're out here setting this fire to clear part of this vegetation away to get rid of the non-native species of plants that are growing here so the native can grow back. We come here and burn annually in different plots of land so that it can be studied, and we can also see the impact it's having on that environment.
A prescribed fire mimics the kinds of mass extinctions that Nemesis may have caused. Many species are swept away, but the destruction leaves room for the survivors to flourish and evolve. Just as mammals survived and thrived after the fiery death of the dinosaurs, setting the stage for human evolution. These prescribed fires return to Santa Rosa every year and imitate the driving motivation behind the creation of the Nemesis hypothesis, that extinctions occur over and over.
There are really only two viable explanations for the regularity of the extinctions. One of them is the Nemesis theory. The other is that by the throw of the dice, they just accidentally happen to line up every 26 million years.
But how exactly would Nemesis trigger extinctions with the regularity of a prescribed burn? The possible answer lies in a region of the solar system known as the Oort cloud.
The Oort cloud is the place where comets are kept in cold storage until they come screaming in towards the sun. So these things are sitting in deep freeze, sort of at the distance halfway between us and the nearest stars.
The vast majority of Oort cloud comets orbit at the safe distance of up to 1 light-year from the sun. That is, unless something disturbs their orbits.
Occasionally a star will come by and they'll get a little bit jostled, and a little jostling can do a lot of things. It can make them go away and leave the sun entirely. It can put them on a slightly different orbit. But one of the things it can do is put them on an orbit that slowly falls in toward the sun.
By following the motions of a juggler, astronomer Greg Laughlin can help visualize why cometary orbits are so vulnerable to the effects of a passing star like Nemesis.
Hey, Greg. So this is Josh Horton, and we've enlisted Josh to kind of help us understand how the Oort cloud really works. How many balls are you actually able to keep up in the air at one time?
That was 7. I can do a little bit of 8 and 9, but 7 is what I practice the most.
The arc of something that a juggler is tossing up is very much like the arc that a comet makes on its eccentric orbit, especially because it's going slow near the top and it's going very quickly near the bottom. If we want to simulate the whole Oort cloud, then we've got to keep a lot of balls in motion. So I'm wondering if you can maybe give me a quick...
Yeah, I can try.
Try to...
Okay, well, let's start with 2.
2 balls.
So what you're going to do here is you're going to cross both balls in here. So it's going to be throw. Nope, the throws are exactly the same, just like the path of the comet. So cross, cross. And they're making an X in the air.
Do they leave at the same time or
no,
different times?
It's right, left, catch, catch.
Right, left,
yeah, that was it. Just throw your left hand a little bit higher.
Right, left, catch, catch.
Good. They're kind of catching them at the same time.
Right, left, catch, catch.
Sounds better.
So I'm a little bit like a solar system where there's some serious gravitational instability in the mix. So Josh is keeping 7 balls in the air at the same time, and that's not unlike the sun's job, which is to keep trillions of comets all orbiting in the Oort cloud.
But according to the Nemesis hypothesis, the sun's delicate juggling act is disrupted by its evil stellar twin every 26 million years. And like something out of a horror movie, this evil twin could be nearly invisible. Does our sun have an evil twin? A star named Nemesis orbiting the distant reaches of our solar system? And every 26 million years, does it fling comets from the Oort cloud toward Earth?
Sometimes they get tossed out, other times they orbit harmlessly until they evaporate and go away. If you have comets rattling through the inner solar system, then in a sense all bets are off.
Scientist Richard Muller not only theorizes that this periodic mayhem is caused by a deadly companion star to the sun, he believes he knows precisely what kind of star it is: a red dwarf.
That there is a star orbiting the sun in a 26 million year period, that was my idea. Let's assume the star is a red dwarf star. Why red dwarf? Because that's the most populous star in the galaxy.
A red dwarf is a tiny star that weighs in with a mass less than 1/10 of our sun. But as astronomer Greg Laughlin demonstrates, it can have the effect of a 9-pound bowling ball tossed into the arms of a juggler playing with fire.
All by itself, the Oort cloud is a pretty boring place, and so we're going to have to up the ante a little bit. So these are going to represent the comets in the Oort cloud.
You ready?
I think I'm going to step back a little bit. So Josh has got them all going nicely, just like the comets orbiting in the Oort cloud. So let's see what would happen if I took this red dwarf and tossed it into the solar system. Josh, are you ready for the red dwarf?
Yeah.
Here we go.
Oh.
So as you can see, the red dwarf coming through the solar system has really changed the orbits of the comets. Notice that 2 of these comets actually crashed onto the Earth. That's not unlike what happens when a giant impact occurs and we get one of these mass extinctions.
For many people, the idea that Earth has been the victim of a series of impacts caused by an orbiting Death Star seems unlikely. After all, when we look at the sky, we only see one sun. But in fact, the majority of stars come in pairs.
Probably something like 60–70% of stars may indeed be binary or have even higher numbers of stars in the system.
According to Richard Muller's Nemesis hypothesis, our sun is part of such a binary star system.
It all works. All you have to do is hypothesize that the sun, like 2/3 of all the other stars in the galaxy, has a companion. This one with a 26 million year period, and there you have it.
But if so, why don't we see the sun's twin in the sky? According to Muller, the reason is simple. Nemesis is an extremely dim red dwarf.
When I first came up with the Nemesis theory, the issue was, well, wait a minute, how come nobody found it? And that was pretty obvious. It has to be hard to find.
By definition, a red dwarf barely glows at all.
It would be the closest star to our sun, and we wouldn't even know it. Now, why is that? The way we discover nearby stars is either because they're very bright, and a red dwarf star is not very bright, or because the sun is moving past it. This star is moving with us. Yes, it's orbiting us, but that orbit is very slow, 26 million years. So it would be moving with us. It would just be at a fixed position in the sky and wouldn't move.
In other words, when viewed from Earth, most nearby objects are shifting over time. But Nemesis is sitting still.